In this video, we're going to talk about valence electrons and bonding. Valence electrons are the electrons in the outermost shell, which is called the valence shell, and they are the ones that are involved in bonding. So if we look at these two pictures of Bohr models, the valence shell is just the shell that's on the outermost area. So this is the valence shell on this diagram. This is the valence shell on this diagram. It's just the outermost circle. The valence electrons are the electrons in that outermost shell. So this one and this one are the valence electrons because they're in the valence shell of this diagram. This one, and this one are the valence electrons in the valence shell on this diagram. So in this valence shell, there are two valence electrons. In this valence shell, there are 1, 2, 3 valence electrons. Keep these numbers in mind as we talk about bonding. Remember 2, 8, 8. If those shells are full, that means that atom has a full valence shell. And just keep that thought in the back of your head. We'll talk about that more in a second. You can find the number of valence electrons using the periodic table. The group is what you want to look at here. So this column is group 1. That means it has each element in that column has 1 valence electron. This column is group 2. That means that each of these elements have 2 valence electrons. We skip the middle and brings us over to group 3. Every element in this group has 3 valence electrons. Group 4, every element in that group has 4 valence electrons. Group 5, every element in that group has 5 valence electrons, and so on until we get to group 8. Group 8 is the most stable group. That means they have a full valence shell. Each element in group 8 has 8 electrons in their outermost shell. Remember, 8 is all you can fit in those last two shells. So that means these elements have a complete valence shell. They're full. They're stable. The opposite is group 1. They are the most reactive. That means they want to bond, which we're about to talk about. So let's just go back really quick and take a look. Lithium, we can see from the Bohr model, it has 1 valence electron. That must mean it's in group 1. Let's check. Yep, voila, lithium, it's in group 1. That meant it had 1 valence electron. Now let's try the same thing for argon. Argon is right here. It's in group 8. That means it should probably have 8 valence electrons. Let's check. Oh, wrong one, sorry. There it is, argon. 1, 2, 3, 4, 5, 6, 7, 8. 8. It has 8 valence electrons. It's in group 8. So now to those definitions which I just kind of started to talk about. If an atom is stable, it means it has a full valence shell. If the valence shell is full, it does not want to react. Every atom is always trying to become full. They always want 8. 8 is great. They want to have 8, so if they already have 8, they just want to stay there because 8 is great. The more valence electrons an element has, the more stable it is. So take a look. Helium has a full 2 full 2 in its valence shell. It just wants to stay. Argon has a full valence shell. It's 8. 8 is great. It just wants to stay as it is. The opposite of that would be an element that's reactive. These are any elements that don't have a full shell, so they're anything less than 8. But 8 is great, so they're always trying to get to that magic number of 8. They react, they bond in order to do this. So these are the most reactive, because the fewer electrons they have, the more reactive it will be. Lithium and sodium are 2 of the most reactive elements on the periodic table. Any element in group 1 has the least amount of valence electrons. Group 1, they only have 1 valence electron. They're the ones that are the most reactive because they have the longest way to get to 8. They want to react. The way they react is called bonding. Bonding is when atoms become chemically joined, and they do this using the valence electrons. Sometimes they're shared, sometimes they're stolen, but we're not going to really talk about the different types of bonds. All that you need to know is that atoms use their valence electrons to create bonds. when they trade valence electrons, it creates a compound. So for example, sodium Na is a metal, chlorine Cl is a toxic gas. You don't want to go chomp on metal, you don't want to go breathe in some chlorine gas, but when those two elements combine by sharing their valence electrons, it makes salt, something that we use every day. Those are the two ways, ionic and covalent, that bonds occur. We're not really going to talk about that, just be aware of it. And a compound is what results whenever bonding happens. It's just when two or more different atoms are joined together. So water, sugar, DNA, your clothes, a tree, a computer, these are all compounds. So if the elements are like the letters, the compounds are the words. So it's the way that elements come together that determines what it makes. So the string of elements that makes my hot chocolate looks completely different than the string of elements that combine to make the grass. So the way the elements combine, bond, determines what it creates. This is going to help you while you do the lab. Just keep remembering that 8 is great. So to be great, to get 8, elements do different things. Sometimes they lose their electrons, sometimes they share their electrons, sometimes they gain their electrons. Just copy this information down, and when you do the lab, it will make much more sense.